Yes, sir. Can anyone say where we need a soft magnetic material and where do we need a hard magnetic material? See, soft magnetic material, they quickly magnetize and quickly demagnetize. Best example for this is transformer. Transformer. You know, to increase the voltage or decrease the voltage, we need a transformer. Okay, so increasing or decreasing. There in transformer, what is happening? It is magnetizing and demagnetizing very faster. So we need a soft magnetic material. In hard magnetic material, we use for permanent magnets. Okay, and for electromagnets, we use soft magnetic material. Here for electromagnets also we use soft magnetic material. Okay, so in toys we need hard magnetic material because children are hitting the toys to the ground, so to the floor. So what will happen? It should not lose the magnetism. So for that purpose, we use hard magnetic material. Hard magnetic material for permanent magnets, soft magnetic material for quickly magnetizing and demagnetizing. Best example is electromagnetic material. Is that clear, all of you?
Yes, sir.
Yes, sir.
Yes, Mr. Aaron, is it clear?
Yes, sir.
Yeah, so here, what happens in soft magnet, I'll give the example for this also. Hard magnetic material, alnico substances, aluminum, nickel and cobalt and copper. Okay, alnico, alloys of for hard magnetic material. Example is what? Alnico, aluminum, nickel, cobalt. Okay, so this is the example for hard magnetic material. And soft magnetic material, what is that? Example is iron, cobalt, nickel and gadolinium. Okay, iron, nickel, cobalt, nickel, cobalt and gadolinium. Okay, gadolinium. These are the material. Okay, for soft magnetic material. So they quickly magnetize and demagnetize. So the Curie constant, the Curie temperature is given here in the tabular column. If you go to page number 194, they have given the tabular column here. So no need to learn that one. They have given the values there. Okay, so they have given the values over there. They will give the values in the examination. No need to worry. Now the next one is I have to explain the BH curve. Okay, BH curve. So in the BH curve, so B is the magnetization. B is magnetism. Magnetic field is measured in what? What is the unit of magnetic field? What is the unit of magnetic field? No one is replying. What is the unit of magnetic field? Yes.
So the
Unit of magnetic field is Tesla or Gauss. Where are you people? Still sleeping. Only 10 days are left to open. School will reopen. Okay. Did you complete your records, all of you? Or still writing?
yes, sir.
Ashas?
Sir, almost done, sir.
Aaron?
Sir, almost done.
Okay. Abid?
Yes, sir.
Did you complete writing the records?
So writing the what?
Record book.
Oh, mine is already complete.
Okay, very good. Now, this is BH curve. In BH curve, we are placing a magnetic material in presence of magnetic field now. So already what happens now? Now, before I start, already there is some magnetic field because of some domains. Like suppose if you take a body magnetic material, out of maybe there are 1,000 domains. Out of 1,000 domains, maybe 20 or 30 domains are already in the direction of the field. Already they are in the direction of the field. So that means there is already some magnetic field is here. So when you start applying the magnetic field, the magnetization increases. Okay. When you start increasing the magnetic field, what happens? All the domains starts aligning in the direction of the field, and they get maximum here. Now when you remove the magnetism, now what happened? You place the material in the presence of magnetic field and started increasing the magnetic field. So what will happen when you start increasing the magnetic field? All the domains start aligning in the direction of the field. After that, what will happen? Suddenly remove the magnetic field. You remove the magnetic field. zero magnetic field. What happens? It doesn't mean that magnetic field will become zero in this material. Okay, maybe 70% will be as it is. 30% will change its orientation. So what will happen now? So here, when you remove the magnetism, it will not become zero. Okay, when the magnetic field is zero, it will not be zero here. So this is A, this is B. Is this clear? First of all of you.
Yes, sir.
See, when you did not apply in the material initially, there were already when you did not give any magnetic field. In the material already there is some magnetic field because of the domains. So when you started increasing the magnetic field in the material also started increasing. So after that, what happened? It became maximum. Then suddenly when you remove the magnetic field, it did not become zero, but already there was some magnetization was there in that material. Now change the direction of the magnetic field. First, earlier you are giving the magnetic field in this way. Now give the magnetic field in the opposite direction. So what will happen now? So it will the magnetic field will go in the opposite direction. Now, are you able to see this one? So the magnetic field will be like this. Now, again, the negative magnetic, that means the opposite direction magnetic field become maximum. All the dipoles or all the domains got aligned in the direction. Now suddenly remove it. So what will happen? It will go like this. It will not become zero. Okay, now start applying the magnetic field again in the opposite direction. So this will become a this one curve. A curve is formed in this way. Is that clear? Instead of going back in the same path, it did not go in the same path. It went in the other direction. So this particular curve is known as BH curve. Okay, BH curve, or we also known as hysteresis loop. Hysteresis loop, named after the scientist hysteresis. Okay, so hysteresis loop. This particular name is known as hysteresis loop. History means lagging behind. Hysteresis means the meaning in Greek it is lagging behind. Lagging behind. Hysteresis means lagging behind. Okay, this is the Greek word. Now BH curve name this curve name is BH curve, hysteresis loop, or lagging behind. This curve is very important in material sciences, and in when we are doing research of finding a new material, it's very important. Why it is very important? Because this will tell you about the magnetic, how it is magnetizing, how it is demagnetizing. It is explaining about all these things. Okay, so now A, B, I'm writing the word letters here: A, B, C, D, and okay. Now this is O. So this is the line. So this is the line which tells about the magnetization. Is that clear? Once again, so we have two names here. When H is equal to 0, B is not equal to 0. That is said to be retentivity. When H is equal to 0 here, when H is equal to 0, B is not equal to 0. That is said to be retentivity. Retentivity means retaining. Okay, it will retain, retentivity. And here one more thing, that is when B is equal to 0. Okay. When B is equal to 0, H is not equal to 0. When B equal to 0, H is not equal to 0. That is said to be coercivity. Coercivity. Once again, see here, when H is equal to 0, see here, this is B and H. Okay, when H is equal to 0, B is not equal to 0. This particular point is known as retentivity. And when B is equal to 0, H is not equal to 0. This particular point is said to be coercivity. Okay, one is retentivity and coercivity. Is that clear? Is it clear, all of you?
Yes, sir.
Yeah. So this I'm writing as here, and this I'm writing as B, and this I'm writing as C. Is that clear, all of you?
Yes, sir.
Yeah. Now Now the last is about the permanent, about the soft magnetic material and hard magnetic material. How it is in soft magnetic material? In soft magnetic material, the BH curve will be like this. See, this came in IIT exam. Okay, IIT exam and NEET exam. Okay, for soft magnetic material, the curve is like this, and for hard magnetic material, the curve is like this. This is for soft magnetic material and this is for the hard magnetic material. Is that clear? So if they're asking you draw the BH curve for soft magnetic material, it should be like this. Means what? It will quickly magnetize and quickly demagnetize. And this one, it will take long time to magnetize and long time to demagnetize. Okay. So this area, what is this then? Sir, what does this area give? What does this area give? This is BH curve. This is also BH curve. Okay. So when we are magnetizing, see what happened first. We keep the material, we magnetize, remove the magnetism, apply the magnetism in the opposite direction. So after that, the full loop is formed. This curve is formed. Now, because of doing continuously, the material will become heated up. For one cycle, this is one cycle. First, we give the magnetic field, remove the magnetic field, again give the magnetic field in the opposite direction, like this, in this way. So what happened due to this? Again, we removed it, made it zero. So what happened due to this? The material will become heated up. It becomes warm. So what happened, whatever the energy we have done, how much energy is required to magnetize and demagnetize, that energy, that if you calculate this area, it will give the energy. That energy is known as heat energy. Understood now? Sometimes he may give the graph, and he may ask you to calculate the heat energy. It's very simple. Just calculate the area of the graph and write in terms of joules. Finish. That's a final answer. Is that clear? Is that clear, all of you? Is that clear, all of you?
Yes, sir.
Yes, Mr. Arham, Aaron, Abid. Yes, Arham and Abid. Is it clear? Arham, Abid, is it clear?
Yes, sir.
Okay, now, so
Yes, sir.
now finish. This completes your almost all the topic. Okay, so once again, we have diamagnetic material, paramagnetic material, diamagnetic material, ferromagnetic material. Dia will not allow the magnetic lines of forces to pass through it. Para, very few lines. Ferro, many lines. Okay, in ferro again we have soft and hard magnetic material. Soft magnetic material, they quickly magnetize, quickly demagnetize. Hard magnetic material, it will take long time to magnetize and long time to demagnetize. Okay, so soft magnetic material we are using in electromagnets as well as in transformers. Hard magnetic material we are using in the manufacture of permanent magnets as well as in permanent magnets as well as in electromagnet. Sorry, in the toys. Okay. Now, so this is the BH curve, which is very, very important. So there are two important points. One is retentivity and coercivity. So B is said to be retentivity and C is said to be coercivity. That means when H is 0, B is not equal to 0. When B is 0, H is not equal to 0. So this is retentivity and coercivity. This loop is named as hysteresis loop or BH curve. Okay, is that clear, all of you? Now, so you know how to make a electromagnet. What we are doing, we are taking a solenoid. Okay, we are taking a solenoid and we are placing a we are placing a magnetic material in presence of solenoid, and then what happens? This material will become an electromagnet. Is that clear? This material will become a magnet. So that is how. So what we do is we can magnetize and demagnetize. So electromagnets are used where? In electric bells, loudspeakers, telephone diaphragms. We are using there. Okay. Electromagnets are used where? Electromagnets are also used live machinery. You know, in the shipping yards. You want to lift the heavy boxes. I don't know what is that. The big what is it? Containers. If you want to lift the big containers, we use the electromagnet. Okay. And even in if you go to dump yards, you want to separate the metals from the plastic, we use the electromagnets. Is that clear?
Yes,
Is that
sir.
clear, all of you?
Yes, sir.
Yes, sir.
Yeah, so
Yes, sir.
this completes your lesson. Okay, this completes your magnetism and matter. For those two derivations, I'm going to send the YouTube link in the WhatsApp chat, so that will complete. Okay, so tomorrow I'll be starting the electromagnetic induction, that is Lenz's law, Faraday's electromagnetic induction. All these I will discuss tomorrow. Maybe it will take 2 or 3 lessons, not more than that. So I'll try to complete as early as possible these 2 lessons. Okay. AC current
Okay, so
chapters. Okay. So please don't miss any classes and please fix a time for tomorrow also. So what time will be comfortable for you tomorrow?
Sir, Adam was saying that we change the time always.
Yeah, what happened? You
Uh-huh.
keep quiet, man. You tell your timing, man. You discuss.
Sir, we told him that any
See,
time in morning
see.
up till 12 or 1 we are free.
Huh? What is that?
Sir, anytime in morning from 7
Anytime
till
in the
1
morning. What about your harm?
Sir, I'm not free in the morning. I have classes.
What time you have class? Can you tell me?
So the entire morning. Then I have from my last class is at 11 to 12:30, and then I'm free for the entire day.
No, 11 to 12:30. Okay. Before that, what time you have class?
So I have I think I'll just check. So it's 9 to 10:30. One is there, and sometimes they take at this also 8 to 9:30.
No, you do one thing, man. Check with your teacher, your chemistry teacher or some other subject teacher.
So
Check with
it's
her
an
and find out.
institute. They have fixed the timings for me.
What is the time they have fixed now? Can you tell me now?
So right now it's from 9 to 10:30, and then 11 to 12:30.
Oh, which
And then and on 1 or 2 days they take in the early morning also.
no. You're taking 2 subjects or 3 subjects? How many?
It's chemistry,
Uh,
but multiple classes to get me up to portions to make me catch up.
but can't you suppose for catch-up classes, they will adjust the classes, right? For catch-up classes, okay. For regular classes, okay. But for catch-up classes, they will give extra, like separately they are taking, right?
Yeah, yes, sir. But in that also the catch-up classes, there are a few other kids also with
No,
me.
I see. My point is because of one or 2 classes, the whole batch is suffering. That should not happen. I'm saying. You got my point. Don't
Yes,
keep
sir.
fluctuating. Fix one time, like 10 to 11. You give physics for physics. Okay. The permanent timing you leave it. Okay. Permanent timing with the institute, the regular batch. That you don't
No,
disturb. Let it go as
sir.
it is. Understand?
Yes, sir. But the extra class also, there are a few other kids also.
Uh,
So we have fixed timings.
because she is also having classes. Okay. Okay, do one thing. Discuss in the group. Okay, maybe now she is not there here. She's in the class now. Later on by evening, you discuss with her what time she is free. So all together finalize one time and tell me. Okay.
Okay,
It's
sir.
very difficult for me, because everyone is having classes. So I cannot discuss with everyone because even Abid is also having mathematics and chemistry classes. Everyone is having classes. So that's what, please adjust your classes and finalize one time and tell me. Okay. Is that clear?
Okay, sir.
Okay, discuss, come to your point and tell me the time. Okay, I will also, even I have other classes. I am adjusting my classes for you people. Got it?
Yes, sir.
Okay, thank you so much.
Thank you, sir.
Yeah.